Okay, excellent. So we all got the drives out. So you're welcome to either keep the data on the drives. You may not have enough room on them, so you may want to actually probably want to run the toolbox. You probably want to copy them locally to your computer. But I think we may have skipped over this part the beginning. But the goals of this boot camp is, Kate and Meg have done a great job with the lectures starting. And so how can we use our cameras to quantify coastal processes? And we understand the theory. So the actual toolbox we're going to go through, we want to be able to process data from a single hovering UAS camera, so a single drone collect, and then also a fixed multi-camera station. So that's what we're going to do through this toolbox. And to do that, kind of peppered throughout all of our lectures, we have these practicums that are going to go through our quantitative coastal imaging toolbox. And so what this toolbox is, it's a set of MATLAB functions, and you can see they're labeled A, B, C, D, E, F, G. And it's kind of like a recipe if you were going to go out and do your UAS collect or set up a fixed camera station, and just kind of a proof of concept. Whereas a lot of stuff Kate talked about with all the equations and things like that, those are all going to be in a little folder that's called core functions. And those are kind of like our ingredients. So, I think we're going to go through today, go through the recipe and kind of just go through the general workflow. And then when you guys do your own projects, you can either copy the recipe and do some modifications, or you can actually take your ingredients and build something new. So, great thing about this coastal imagery is I always use this bakery analogy, is that you can do a bunch of different things with like the same core functions. So you can make a cake, you can make bread, pizza dough, and you end up just using them slightly different ways. You can do a lot of different things. So I'm going to start just by getting everybody kind of set up. Oops. So if you guys want to open MATLAB, if you have it. So your workspace, you want to bring your workspace to under Bootcamp Workspace and then CIRN QSIT. And so this should be where you are. Does anyone need help getting to this spot? You guys won't have this folder, so don't worry about that one. And so also, we're going to try our best to have it so you guys can actually see it in the back. So let me know if you need the font bigger or smaller. I'm happy to do that. And so, okay. And then let me pull up the actual presentation. So we're going to do extracting frames first. The reason why we're doing this one before the lens calibration demo is that a lot of times when you do your lens calibration, you actually are going to need to use this function to extract frames. So that's why we're kind of starting here first. But it's really simple. It's literally all it is taking a movie that you collect from a UAS and put it into frames. Now, if you have a lot of Argus type images, cameras will just give you frames, so you could probably skip this part. So it's going to be the function movie to frames. And then we'll just kind of, all of the practicums are going to have this format so that we'll show. So what we're going to go through this whole process is we're going to do UAS demo data. So we're actually going to do a UAS flight because it's the most complicated. And then at the end of the lecture, we'll kind of go back and do the fixed multi-camera station. And so we'll go through this. So we'll just go through this. There you go. But again, and we'll kind of talk about this, but this is more for your reference, this slide. But all we're doing is getting frames from videos, and what kind of frequency you want to try to get rounding errors, the constant DT, and a good naming convention for your images to keep them in order. So this is the function movie to frames. So we try to put a lot of detail and descriptors in there. And so what functions it requires, things like that. So everything in here should be pre-populated. Now I'll just kind of go through. So you put your movie path, so that should already be done. And so you can see on the right here, we have our UAS demo data. So this has already been formatted, organized to make things more clear. Now, you don't have to have it organized like this to have everything work for your own projects. However, this is just a good example because we'll find out tomorrow when we do a live collect, organization is key. And so we have in our little collection folder, we have our movie. Now, all of the, I will say, everything in this toolbox has been pre-populated, so all the steps have actually been done already. We, however, just have not, that's so you could jump around and try different steps as we explore. But if you were to do it from scratch, it wouldn't be the case. So basically we have the file path where the movie is located. We have the base name for the image files. So we try, to have something descriptive of what type of camera it is, the location, what type of lens you're using, but we're keeping it simple right now and just doing UAS demo. And then all the directory where all your images will be saved. Again, try to do something descriptive, UAS demo, 2 hertz. You may find that's too much. You go back, do UAS demo, 1 hertz. And then right here is really important where if you don't necessarily know if it's not embedded in the metadata, the actual time in the local time coordinate system that you want. So it depends on your purposes, how detailed you want this. So if you're trying to compare to another in situ instrument, string like image by image, you want this very accurate to the second, to the millisecond. If not, you could probably, if you just kind of want the general tide, right? Probably within an hour or two. And a good way to actually explore, ideally when you're collecting, and we'll go through this tomorrow in the example collect, you're going to be writing all this stuff down. So you'll just have a pen and paper and you can look at it and be like, oh, that's my time. And we'll put it right down there. But another way to do that if you forget, because things are easy in the field, is typically I found with these UAS, you go to the properties, it's generally not the created date, it's the modified date, and it's the end of your frame collect, at least in Windows. So if you look at your video, it was 5 minutes long, it says date modified, it was probably taken at 45-ish. And so this video is actually, we've made it and unmade it, so it's actually not matching because you can see it doesn't say 2015, like I said, but your real images, your real videos will typically do that. And so also just be careful when you do that. It'll usually say the local coordinate system of the computer you're on, or time zone of the computer you're on. It may not be the one you want. So there's just also that note too. And this is where you enter your frame rate, and then you basically hit run and it should go. Now, don't do that yet. So it won't this time because our frames, the data was actually too big to put on the drive, so we removed our frames. So we may need help here. So everyone, if you don't mind showing me, under UAS demo data, under collection data, do you all have a folder that says UAS demo 2 hertz? Okay, could you all make that folder in that directory? That would be great. So in order for this to work, the folder has to already exist. So just make an empty folder. So it's UAS demo _ 2 hertz. Okay, is everyone good? Okay. Okay, sorry. I'll let me see if I can make it like super big real quick. Let's see view. See. There you go. Nope, not that one. There we go. UAS demo 2 hertz in the collection data folder.
Feel free to raise your hand at any time if you need help and somebody can come around.
Yes.
For sure.
Oh, you want to zoom in? Okay.
Made the folder. What's its name? I think it's Chris.
Okay. So after we get that, ideally, it will work. So if you want to see, so I'm going to hit, oops, this editor. So I'm going to hit run or F5. And so what happens is you'll see, it'll go through pretty fast. This is a fast computer. It's going to give you your percentage of your extraction that's complete of the video down here. It will show you the frame rate, your specified frame rate. And so it will show you what your actual, what you specified the DT to be and the actual DT. A lot of times something will be running at 30 frames per second, but it's actually 29.8 or something. And sometimes that can cause some weird things. So this is just a check. Now we made this video, so we know exactly it's at 2 hertz. But so if you guys look in here, you will have a folder that has a bunch of images in it. And so this is in epic time in milliseconds. And so we found that that's the easiest way to also keep MATLAB reading it in order as well. And so, and to also include milliseconds without having an extra dot in it. So, so that's where that is. And so that is how you extract frames. And that was a complicated way of doing the easiest part.
And if you're running the code from your USB drive and trying to save the USB, it's going to hang up because there's not enough space on the USB for all the extracted frames. So, well, you might have to copy it to your local computer to be able to run and extract all the frames.
And that being said, you know, I just put a random on this code. Not random, I just put the basic write an image for your own projects. If you guys want to add compression, make it a JPEG instead, you know, that's, you can do that. Yep. Okay, so a couple of common things we're seeing is we have to make that folder. And then this, we have to actually be in this workspace. So you have to double click and be in that workspace. So.
And there's a folder.
Yep.
The frames are not supposed to be, so make sure this is not. You do that. So just navigate until this. Is that not highlighted?
Ah, that was a mistake.
So they're not in your path.
So there's just a difference between like what MATLAB is treating it.
40.
How many did you get?
Yeah, so just as it's stopped.
I think there's something with the codec between the different computers.
So as a temporary solve, they just changed the number of points.
Yeah, I'm hoping.
Yeah, like when I'm making I was like, he's supposed to be literally that.
We may need a copy just so the number of frames is equal with everybody. We may need to, if there's different codecs for the future steps, but we'll just go through it. So like it should still run from start to finish.
Brittany, so we're getting 39 frames, but for now, it's just on my 99. I have one. That's it. Now it's
What the duration of that frame rate?
That must be a weird codec thing. I think either way, it should be your last number.
Right.
Well, so I was stopping here, and now so I was over.
Okay. Then I would go ahead and, yes. I think it should work either way. So basically, like, if you were to go and skip ahead to like step E, it would work because it was all based on 40 frames. But if we go through the whole thing again, it should work with it.
Well, no, but I'm saying now that I put this in, I now have 40.
Oh, yeah. No, I'm just saying that way. It also could be a MATLAB version thing as well. So I think
Various.
okay.
So I now have, like when you put in the negative, when you surpass it, you're sort of like going down.
What's
You know,
format that video?
So I think I don't know what codec it was. Okay, so are we generally in a good place to move forward? Okay, cool. So Jenna's gonna go into intrinsic calibration distortion. So the idea was basically so you picked out your camera, you got it, you took your pictures, now you got your frames.